Good morning, Quadcopter 101 here, and I got a really neat airplane for you today. This is the C17 RC aircraft. What's so neat about it? Well, it has gyros. Supposedly it has gyro control. I don't know how you implement gyro control because it's only two-channel aircraft controlled strictly by, what do you call that? Thrust of these two motors. Okay, it changes the thrust on one particular motor to control the aircraft. You know, if you want to turn to the left, this one produces more thrust. If you want to turn to the right, this one produces more thrust on the left side. And somehow that is supposedly able to also control things such as phugoid oscillations. I don't know how, but supposedly it can. And also control, you know, the amount of bank that the quadcopter or the airplane goes into. It's supposed to control that too, the gyro sensors. It's all controlled via this electronic board down here. Now, another thing about this, why is it so cheap? You know, this runs a little over $20. Well, it's because it comes fully disassembled. You have to assemble this yourself with glue. You know, it's like building a model airplane, which can be fun. I actually enjoyed building this, but again, it's completely disassembled. You have to put everything together. You know, you have to install the motors, you have to install the landing gear, install the wings, install the engine pods onto the engines. You have to install this horizontal stabilizer to the rudder here. Again, completely disassembled that you have to assemble. So it took me a couple hours to put it together, so expect that. And that is the reason why it is so darn cheap, $23. Again, it's two-channel aircraft controlled strictly by differential thrust of these two motors. You get a two-channel controller, and all you got with the controller is throttle control and turning yaw control. But again, supposedly this also has gyros that it will stabilize it, make it easy to fly, and we're going to find out shortly here. You also have trim for the yaw. Now the thing is, it's opposite of what you think. You know, if you normally you press the left trim and it will start to turn left, but when you press these buttons here, if you press the left trim, this is increasing the thrust on the left motor, and it's going to turn to the right. So it's opposite of the way you think. So keep in mind, whatever button you're pressing, that side motor is going to be increasing its thrust to push it that way. So think of these as push trim instead of yaw trim. Okay, that is about it. Very simple controller, on-off switch. These buttons here don't do anything that I'm aware of. It's not in instructions. So let's go for a flight of this thing and see how it performs. First thing off, we turn on the airplane and put it on a flat level surface, relatively flat level surface, and turn on the transmitter and bind it to the airplane. We should be bound. And then notice, increasing the throttle turns on the propellers. Now let's watch what happens when you turn to the left. The left or the right side has more thrust, and when you turn to the right, the left side is pushing to the right. So let's take to the air from the ground and see if it actually can do a ground takeoff. So, increasing throttle. I don't know about that. Oh my goodness, there we go. It took a lot of runway, but it took to the air. I'm surprised. And yes, okay, reducing throttle because it wants to climb. My gosh, took a long runway to do that. Let's turn it to the right and bring it back toward us from the right. It seems to want to turn to the right, so we're going to give it more push on the left. Oh, I was wrong. Going into the sun, folks. It's gliding now. I want to bring it down lower so you can see it. So reduce the throttle, gliding it down. Neat. From the distance, it looks like a real C17 in the air. Okay, let's bring it by close flyby. It requires quite a bit of turning radius there, even though it's small. I want to bring it for another close flyby. Uh-oh. That seems to be its range there. When it goes out of range, it goes into a glide. So the range there was about 80 meters, which I guess is good enough for this little airplane. Trying to bring it for a close flyby. I still got all the wheels on it. That's what I was worried about. Its right turn seems to be better than its left turn. So I probably need a little bit of trim on the, pushing it to the left a bit more. I'm going to go a little bit closer here, raising up my, there it goes again. Out of range. I need better batteries, I guess. I put too much trim that way. It only takes a few batteries, folks. It doesn't give it much range, so you want to stay, keep it relatively close to you when you're flying. But it goes into a glide, nice glide when it runs out of power. I'm trying to do figure eights here. Yeah, it's doing them. So yeah, what was those airplanes I like? The Fly Bears. This is similar to the Fly Bears, differential thrust, about the same price as the Fly Bears, but you're getting pretty neat airplane for the price. I like it. It's a good flyer in that no phugoid oscillations. So it's either well balanced and I doubt that that's the case because I did not do any balancing of it, or those gyros somehow do work. I just don't know how it knows to balance the airplane. It doesn't let you go too hard over. If you give it full throttle or full pitch in one direction or full yaw in one direction, it doesn't let you exceed a certain amount of pit or angle of bank. See, I'm full left right now, and it's not letting me go any further than that. Full left. It just prevents you from doing such. So I think that's the main thing it's doing. And otherwise, no phugoids. I guess it's just well balanced. I can't see a two-channel control preventing. Oh, there goes a hawk after it. Oh, you didn't get it. Come on, go for it. Let's see you go for it. Yeah, he tried to get it. Did you see that, folks? He gave up. He figured out it wasn't a small bird. This is something I've never seen before. And the hawk gave up. Going into the sun, something I shouldn't do, but yeah, look at that. I'm giving it full. It doesn't let you do it. Oh, here he comes again. That wasn't a hawk. I don't know what that was, but he's chasing it. Okay, I need to put better batteries in this transmitter because I'm exceeding its range. Fun airplane. C17. Build it yourself. Not too hard to build. There's one thing I want to tell you about building that, though. I'll have to show it to you when I bring it in here. But it wasn't very clear which motor goes on which arm or which wing, and it's very important that you put the correct motor on the correct wing. And that's the motor with the white and black wire. That has to go on the right wing. That is your right motor. That's shown in the instructions. The one with the white and black wire is on the right wing, and the one with the red and blue wire is on the left wing. So keep that in mind, folks, when you're building it. White and black, right wing. Neat airplane. I know a lot of people are going to want this now. because it's so neat. And it does have gyro control, preventing you from going too far over when you're making a bank turn. It prevents it. Full hard right rudder, and you can still go into the ground, but it won't go over. It won't go upside down on you. I wonder how long it flies. We'll find out. It is powered. I didn't mention that. It's powered by 300 milliampere hour generic white Losi connector battery. So you can get more batteries for this easily and keep on flying, but I would let those motors cool down before doing such. You know, don't fly too long. You know, don't just pop a new battery in. Let the motors cool a bit between flights. I'm pressing these trigger buttons to see if anything happens, but I'm not seeing anything different. I turn to the left. Neat airplane, C17. I guess it's better to hand launch it. Let's try hand launching that thing. Bring it in for a landing here. I'm going to try a hand launch. Land it. Let's see if it hand launches easily. I haven't done that yet. See, I was going across a sandy surface, so there's a lot of drag on those wheels, a lot of friction on those wheels. So that's why the takeoff was probably a little bit difficult. The lights are starting to blink, means we're getting low on power here. But let's try a hand launch. I'm going to throw that way, because the wind feels like it's coming from that way. Easily hand launches, easily. So, yeah. I think we're low on battery. So we're going to be coming in here shortly, yeah. So let's land it. Now, let me show you real quick the two things before we shut down here. Let me turn off the transmitter first so I remember. And turn off power on the quad, or the airplane, not quadcopter. Yep, its lights are blinking. Again, this is the right wing. See the black and white wire on this wing here, on the right wing, and the blue and red wire here on the left wing. So keep that in mind. And additionally, the battery for this is just a generic 300 milliampere hour battery. Let me take it out and show you. I'll even give you the size of it. But you could probably put 350s in here. There's plenty of space in here for other size batteries. But this one is a little 300 milliampere hour. Let's see, get the number off of it. 70, 20, 30. So 7 millimeters thickness, 20 millimeters width, 30 millimeters length, but this could probably take larger 1S batteries with white Losi, you know, 350, maybe even 380. But it works well with the 300 if you can get them. So that's the C17 with gyro control, or gyro stabilization, particularly for banking turns. Hope you enjoyed this review. This is Quadcopter 101, signing out.